Alright, on section 2.6 we're finally going to get to some calculus called the derivative. The first thing we're going to look at is the average rate of change given a graph. Now that sounds very fancy, but all that is the slope of a tangent line. And I want you to remember that throughout this lesson. Right? And then the book calls this a four-step process to find the slope of the tangent line. We can shorten that. And then we're going to use the definition of the derivative in some particular problems. But first of all, let's just look at what a tangent line is. A tangent line is a line that's just going to touch a curve in one particular point. Sometimes that's hard to see. Alright, so you've got this graph here that's curvy, alright, and apparently it is the volume of wood produced in a forest. Right, so you can see that if you drew different tangent lines, those tangent lines have different slopes. Like this one has a smaller slope than that one because it's less tilting. Alright, so we're going to find T1, which is the slope of this first tangent line. Now if you recall, the slope is rise over run. Alright, and so we're going to be asked to find the average changing at the beginning of year 10. So they've drawn us a tangent line at year 10. Here's this line, and if you look real carefully, they've made this little bitty triangle. Well, that's the rise and run. So the run is from 10, well, a little bit past 20. They tell us it's 12. So the run is 12. And the rise is 4. So the slope of this first tangent line is just 1 over 3. Right? Now we should expect the slope of the second tangent line to be bigger than 1/3 because it is a lot steeper. And so that's where they're asking us to look at the average change or the slope at year 30. And again, they've gone up here. They put a dot at year 30, they've drawn a tangent line, and they've done this triangle thing, and they've done rise over run. Now notice that that 10 is going all the way up to the tangent line. It doesn't stop at the curve, right? So we want rise over run. Well, the run was 8, the rise was 10, and so if we reduce that, that's 5 over 4, and that is definitely larger than 1/3, which is what we expected. So the first couple of problems, you're just looking at a graph. Alright, so now let's just look at a regular graph. Okay, let's review what is a secant line. A secant line would intersect a graph in more than one point, in 2 points. So if I looked at this line 1, that would have a particular slope. Alright, it would be positive, it's rising. But if I kept this point the same, but moved this point closer and closer and closer to the point that I've marked with an X, the slopes of those lines would definitely change, right? In fact, it would get flatter and flatter until we came around here really close, and we would even have a negative slope. So you can see that it changes. The idea is of a derivative is instead of a secant line that we move those dots so close to each other. Let's say we have this dot and this dot. Alright, so we can find that secant line. But what if we took this dot and that dot right next to it? It would eventually become what's called a tangent line. Now, let's go back to the slope that we learned in high school. Remember y2 minus y1 over x2 minus x1. Alright, now this is the run, or the space between the x's. The idea here is that we're going to let that space approach 0. We're going to let the limit approach 0, and that's how we're, instead of having a secant line, meaning 2 spaces, or 2 x's, we're going to be on top of each other where the limit is 0, and then we get a tangent line. And that is the derivative, right? So let's just look at the definition of the derivative. All right, if we go back to the slope that we learned in high school, is that we could rewrite that as f of x2 minus f of x1. Okay, just a fancy way of writing it. But how about, instead of saying x2 and x1, all right, let's say we have a space of x, and all right, we've got that curve, and I want to move over a distance of h. Well, how about this would be f of x plus h minus f of x over just the distance of h. Now, that's a fancy way of saying this distance becomes h. That's the difference, or how far apart the x values are. And these are the y values associated with that. All right, so now, what is the derivative? We're going to take the limit as h approaches 0 of what's called the difference quotient, or the slope of a line. And that is the definition of the derivative. And all the derivative is the slope of a tangent line at a particular point. Right? I would encourage you to look at page 137 in your book. Right? But this is what we want to concentrate on. Right? So after you look at some graphs and things, they're going to then ask you to use this 4-step process. Now, truthfully, I don't care if you do it in 1 step, 3 steps, or 4 steps, but a lot of people need that 4-step process. And we're going to use the 4-step process to find the slope of a tangent line to the graph at a given function. So I'm going to look, let's say we have f of x is equal to 5. Well, now, let's back up. It's a 4-step process to find the slope of a tangent line. Well, let's just use our brain. Instead of using calculus and all this fancy schmancy stuff, what does that graph look like? This is a graph of y is equal to 5. If I were to graph that, that is a horizontal line. Well, if I want the slope of a tangent line, well, first of all, I can't draw a tangent line. I can't touch a horizontal line only at one point with another line. A line is just going to come right on top of it. So what would be the slope of a horizontal line? Well, hopefully you remember that the slope is 0. Right? But if we were to go through this definition of f of x plus h minus f of x over h, and then we would take the limit. Well, let's see, what would that be? If you notice, f of x is 5. There is no x to put in there, so the numerator would just be 5 minus 5 over h, which is again going to be 0. So I don't think a 4-step process is really necessary. If you know that it is a 0 slope, write that down. Right? How about this? We have f of x equals negative 3x plus 5. Well, we're going to go through the definition, but I want to go back to basics of what is this. This is a graph of a line. Hopefully you remember y equals mx plus b. So it intercepts at positive 5 and has a slope of negative 3 over 1. So that is the graph of a line. So if I'm asked to find the slope of a tangent line, well, you can't have a tangent line to a tangent line. It's just going to be, again, a line on top of a line. So what is the slope of this line? Well, comparing this, we should know the slope is negative 3. And if that's what you wrote down, that is fantastic. But if I had to go through that definition of f of x plus h minus f of x over h and then find the limit. Well, let's see if we can do that. All right, remember from previous sections, we're going to come back up here and substitute in x plus h in for x. So we're going to substitute in x plus h in for x. Don't forget the plus 5. Then we're going to subtract the given function, and then we're going to divide by h. All right, so let's keep going. If I distribute that, distribute my negative, all right, start collecting like terms. You'll notice you're going to get negative 3h over h, which is negative 3, which is what I got just by knowing that it's the slope of a line. So these two examples show you if you have a horizontal line, the slope is always 0. If you want the slope of a tangent line to a line, it's just the slope of the line. So that can't be what calculus is for. All right, let's get into some nitty-gritty. What if I give you f of x is 2x squared plus 1, and I want to find the slope of a tangent line? Now, if you remember, this is a parabola that looks something like that. So the slope of a tangent line is going to vary depending on where I want that tangent line. If I wanted a tangent line way up here, then my slope's going to be very positive. But if I want a slope over here, or a tangent line there, very negative. And if I came down here, I'd have a slope of 0. So obviously the slope is varying. All right, so let's see how it is varying. All right, so the first thing I'm going to do is start out here. So I'm going to replace x with x plus h. I'm going to subtract my original function. Then I'm going to divide by h. Now I think in the earlier section I wrote out more steps to this. I think I wrote it out vertically, and if that helps you, that's fine. But just trying to show you a different way. All right, so here I'm going to FOIL this out. Going to distribute my minus. Now I'm going to start collecting like terms, and things should start canceling. So I have 4xh plus 2h squared divided by h. You can factor out that common h. Okay, so in a previous section we would have stopped. That was the difference quotient. But now we want to go one step further. To find the slope of the tangent line, we want the limit as h approaches 0 of the previous result. So remember, from limits, we just substitute that value in for the variable. So in this case would be h. So that would be 0. So I'd have 4x. So this is the slope of a tangent line. Now you're saying, well, but that's not specific. That's right. If you come back to this picture, depending on what x is along this graph, you're going to have a different slope. So if x is 0, like right here, you're going to get a slope of 0. If x is, say, 2 or 3, you're going to have a very positive slope. And that's how we get a slope of a tangent line to a parabola. Right? We want the slope. Again, a 4-step process. The book just breaks it down like I did in the previous section. Right, so I'm going to find, so the book, step 1 would be to find f of x plus h. And let me do an example in that 4-step process. And that's how I did it in a previous section. All right, so we would say this. All right, so I'm going to FOIL this out again. Now I'm going to distribute my negative. Whoops. Okay, so then my second step, all right, f of x is just the given function. But remember, we're subtracting it. So if you recall, I would go through and change my signs. And now instead of going across the page, again, this is just an alternative way to do it, is I would cross that out, cross that out, cross that out, and I would have left, right? So the third step would be to divide by h, right? So since they all have an h in the numerator, and then the fourth and final step would be to take the limit as h approaches 0 of that, and again we're looking at h, not x, so as h approaches 0, that becomes 0, and I have negative 2x plus 3, and that would be the slope of the tangent line. Alright, now this, just to tell you, this is number 20 in your book on page 146. And what it's asking you is to find the slope of the tangent line, but at a specific point, and then we're going to determine an equation of the tangent line. So we're going to go one step further. Instead of leaving it as a variable in the slope, we're going to go through and actually plug in numbers. Right? So the first thing we have to do is find the derivative. Okay, so I'm going to work this one horizontally instead of 4 steps, just kind of doing it all in one. Okay, so that would be 3x minus x squared, substituting x plus h in for x. And then I want to subtract my original function. And this time I'm going to start collecting like terms, and some things should cancel. Okay, and since they all have an h, I'm just going to reduce it. You could factor it out. Right, so but what you would have left is a 3, a minus 2x, and a minus h. And then the last thing we'd want to do is take the limit as h approaches 0. And again, that would go away. Okay, now that's the slope of the tangent line at the function 3x minus x squared. So that's at any point. But the book asks us to do at a specific point. Alright, so what do I want? It says I want to find the slope of the tangent line at a given point. Alright, so now I'm going to let x equal to negative 2. So I'd have 3 minus 2 times negative 2. What is that? 3 plus 4 is 7. Alright, that is the slope of the tangent line to this parabola at this point. Now I want to determine an equation of the tangent line. Okay, so now I've got to go back to some really basics. I've got to know how to find an equation of a line. I'm going to use the point slope form because that's what I have. I have a point and I have a slope. That's very convenient. So I have y minus a negative 10 equals the slope times x minus a negative 2. So we have y plus 10, 7x. I think that's going to become positive. If I distribute, that's plus 14. Okay? And that is the equation of the tangent line to the parabola at a specific point. We're going to be doing that a lot. All right? So, this is not a parabola. If you were to graph it, I'm not too sure what it would look like. Okay, but it's definitely not a line. Right, since the x is in the denominator. So this is going to be a little bit harder. Right, so again, I'm going to kind of just do a couple of examples each way. So I'm going to go back to that 4-step process and say, what if I wanted to do that first? Right, so the second step says, what is f of x? And if I wanted to subtract it, then I would have to change the sign. Oh goodness. Okay. The third step then says to divide by h. Well, I've got some work to do, I think. All right, before I take the limit as h approaches 0, I've got to clean this up. So I'm going to find a common denominator. All right, so I'm going to multiply this fraction times x, and I'm going to multiply this fraction times x plus h. Okay. So let's see. My common denominator is 2 times x plus h. So on the top I'd have negative x plus h. And yes, I'm still dividing by that h. Alright, collecting like terms, I get this. Alright, now how do you divide by h? That would be the same as multiplying by its reciprocal. Now you can see how convenient that would be. And then the last step I'm going to do, I'm going to take the limit as h approaches 0. I have 1 over 2x times x, which is 1 over 2x squared. Now that is the slope of the tangent line, or in other words, that is the derivative. Okay, but the book wants us to go one step further. All right. We're going to find the equation of the tangent line at this specific point. Alright, so I want the slope at a point. So we're going to let x equals to 3, and that's my slope at the point here. Now I want the equation of the line. Now at this point, again, I'm not too sure what the computer asks you to put it in the format of. We could solve for y. Let's do that. So if I distribute my 1/18, let's see, 3 over 18, 3 goes into 18, what? So then if I subtract 1/6 from both sides, okay, that would be the equation of the tangent line to the graph of 1 over 2x at that point. Let's be asked, let's see, the book is going to ask you, how about to find the derivative? And they're going to use this notation, right? It's an F with a little slash, all right? So we're going to find the derivative. All right, so we're going to go through the process. And remember, the derivative is the difference quotient, which is this, as the limit as h approaches 0. So you can see this time, instead of doing the 4 steps, I'm just going to kind of do it all in one. Pick a way that you feel comfortable. Okay, and you're going to reduce. Okay, they all have an h, right? Here, 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 and here, so I can cancel out an h. Okay. And now the last thing I want to do is I want to take the limit as h approaches 0, and I would get 2x plus 2. So that is part A, to find the derivative. Well, now, what if I say to find the point on the graph where the tangent line to the curve is horizontal? I want the tangent line to be horizontal. Well, if you recall from that example previously, a horizontal line, the slope is 0. So they're asking you to find the value of x where the derivative equals to 0. Here's the derivative. So I want to say, when is this derivative equal to 0? So I just solve for x, right? And it says to find the point on the graph. Well, this says when x is -1, the slope is 0. But what was that original function? It was x squared plus 2x. Right? Now remember, f of x is the same as y. Alright, so we're going to say y equals what when x is -1? So let's see, that's 1 minus 2, which is -1. So the slope would be 0 at the point when x is -1, y is -1. Don't worry about sketching a graph. I'm not going to ask you to do that on the test. If the computer asks you to do that, you may use a graphing calculator, but don't really worry about that part. Okay, this is number 27 in your book, Part A. It asks you to find the average rate of change. This would be the slope of a secant line, all right? And so the average rate of change really goes back to just the slope of a line. Now remember, that top part is the same as y2 minus y1, right? So this is the average rate of change. So part A on number 27 says to find that from the interval of x is equal to 2 to x is equal to 3. So I'm going to call this x2 and that x1. All right, so let's see. If I evaluate the function at 3, that's 3 squared plus 3. Remember, I'm looking at that function up here, was at 12. F of 2 is 2 squared plus 2, which is 6. So if I want the average rate of change, I want 12 minus 6 over 3 minus 2. Right? Pretty easy. They also ask you to find it from x equals to 2 to x equals to 2.5. They're just trying to go back to that idea. The secant line, as those two dots get closer and closer and closer, you're eventually going to arrive at the slope of the tangent line. Right? So we're going to do the same thing. Right? So f of 2.5, 8.75. F of 2 is still 6. Right? So we're going to So we have 8.75 minus 6 over 2.5 minus 2. And we get 5.5. So a little bit different than 6, okay, because those two values of x they're getting closer and closer. All right, so then they say, well, you know what? Let's do it even closer, as x is 2 and x is 2.1. And again, I'm going to be consistent. So let's see, f of 2.1, oops, f of 2 is still 6. So I'm going to use this same formula right down here. So I have, let's see, 6.51 minus 6 over 2.1 minus 2. Get 5.1. Okay, so I started out with 6, then I've got down to 5.5, 5.1. So maybe as that gets closer and closer, maybe we'll get a slope of 5. Let's check it out. All right, so on part B, it asks us to find the instantaneous rate of change. That is the derivative, and they want the instantaneous rate of change at x is equal to 2. All right, so let's see, remember the function was that. So I'm going to take the derivative and then let the limit as h approaches 0, because that h is the distance between the x values. So we went from 2 to 3, from 2 to 2.5, 2 to 2.1, so we're getting closer and closer. Now we're going to be exactly at 2, so we'll have a tangent line. All right, so let's see. We would have, okay, we can reduce our h's because they all have an h. Don't leave out that 1 at the end. H goes into h one time. And then we're going to take the limit as h approaches 0. So that's 0. And I get 2x plus 1. All right, and now we need to find the instantaneous rate when x is 2. So we're going to plug in 2 right there. 2 times 2 plus 1. Lo and behold, it's 5. All right, so when they ask you to compare the results, hopefully you can see that we went from an average rate of change, the slope of the line, rise over run, like we started out with on the graph, and then as we let x get closer and closer together, we get an instantaneous rate of change, and that is the derivative. That's the slope of the tangent line.